This project focuses on porting junkyard LS cathedral port heads using cost-effective $50 carbide burrs. By showcasing affordable tools and techniques, it aims to make performance upgrades accessible to budget-minded enthusiasts. The LS engine community is known for its creativity and resourcefulness, and this approach fits right in. Whether you're a seasoned builder or just starting out, learning how to maximize gains without breaking the bank is always appealing. LS. Cathedral port cylinder heads are a distinctive feature of many General Motors LS engines. Known for their unique shape, these heads offer excellent airflow and efficiency, making them a popular choice among enthusiasts. Despite their advantages, common issues include potential cracking and valve guide wear, especially in high-mileage or heavily modified engines. Their widespread availability and affordability make them especially attractive for budget builds, allowing builders to achieve impressive performance without breaking the bank. This combination of performance potential and cost-effectiveness has cemented their reputation in the automotive community. For the porting process, a variety of specialized tools and materials are required to achieve precise results. One of the most important tools is the carbide burr, which is used for shaping and smoothing metal surfaces within the engine ports. While there are many options available, investing in $50 carbide burrs strikes an excellent balance between quality and affordability. These burrs offer durability and efficiency, allowing for consistent performance without the high cost of premium alternatives. By choosing cost-effective tools like these, enthusiasts can complete the porting process effectively without exceeding their budget. Begin by thoroughly cleaning the LS cylinder heads to remove any oil, carbon deposits, or debris. Carefully inspect the casting for cracks, warping, or other signs of damage that could affect performance or safety. Use a straight edge and feeler gauge to check for flatness across the deck surface. Examine the valve seats, guides, and combustion chambers for excessive wear or pitting. Once the heads are confirmed to be in good condition, mask off sensitive areas like the valve seats and guides to protect them during the porting process. The porting technique involves carefully smoothing and reshaping the intake and exhaust ports to improve airflow. Using basic tools like a rotary tool with sanding attachments, start by removing any rough edges or casting marks inside the ports. Work gradually, focusing on creating a consistent surface without removing too much material. Pay close attention to transitions and curves, as these areas can significantly impact performance. For best results, periodically check your progress and ensure both sides are matched for optimal efficiency. When working with carbide burrs for head porting, safety should always be the top priority. It is essential to wear protective eyewear and gloves to guard against flying debris and accidental contact with the sharp tool. Ensuring the workpiece is securely clamped will help prevent movement and potential injury. Always operate the burr at the recommended speed to maintain control and avoid overheating. Regularly inspect your tools for wear or damage, and keep your workspace clean to minimize hazards. When comparing stock intake and exhaust ports to their ported counterparts, several key differences become apparent. Visually, ported ports often display smoother surfaces and more streamlined shapes, designed to optimize airflow. Measurable improvements typically include increased port volume and more consistent cross-sectional areas, which help reduce turbulence and restriction. These enhancements can lead to better engine breathing and, ultimately, improved performance. The contrast between the two highlights the benefits of precision porting over standard manufacturing processes. Here, we present the flow bench results recorded before and after the budget porting process. Initially, the airflow measurements indicated several restrictions within the cylinder head. After the porting work, the results reveal a marked improvement in airflow, demonstrating the effectiveness of even modest modifications. These gains highlight how careful, budget-conscious porting can lead to significant performance enhancements without the need for expensive upgrades. Improved airflow allows an engine to breathe more efficiently, ensuring that a greater volume of air reaches the combustion chamber. This increase in oxygen enables better fuel combustion, resulting in more power generated with each engine cycle. As a direct outcome, engines with optimized airflow often experience noticeable gains in horsepower and torque. Enhanced airflow can also lead to smoother acceleration and improved throttle response, making vehicles feel more responsive during everyday driving. Ultimately, these improvements contribute to both better performance and increased driving enjoyment. The next phase of our project brings us to the dyno, where we'll put our porting work to the test. This is where theory meets reality, as we measure the true impact of our modifications. The anticipation is high. Will the performance gains match our expectations? Soon we'll have concrete data to reveal just how much power we've unlocked. Stay tuned as we prepare for an exciting round of dyno testing. To recap, budget porting is a practical and rewarding approach for LS enthusiasts seeking improved engine performance without breaking the bank. By carefully modifying the cylinder heads, significant gains in airflow and power can be achieved. This process allows hobbyists and builders to maximize the potential of their engines using accessible tools and techniques. Ultimately, budget porting offers a cost-effective way to enhance performance, making it an appealing option for those passionate about getting the most from their LS engines. In summary, this project demonstrates how thoughtful, budget-friendly upgrades can significantly enhance both the performance and aesthetics of a build. By carefully selecting affordable components, it's possible to achieve impressive results without overspending. These improvements not only extend the lifespan of your system, but also provide a more enjoyable user experience. Consider exploring similar upgrades for your own setup to make the most of your investment.